Here is a house we just got done building where I work. For my final project for ENT 358, I'm going to explain the electrical components of this house and how it gets electricity from the pole and service to the house and the breaker box and the components inside. So here we have the pole. These are your power lines from West Kentucky Rural Electric. The top line is your primary line. I think West Kentucky has 14,400 volts run through their primary. So there's one single primary at the top of this pole. The line below the primary, which is the second line from the top, is your neutral line. The bottom lines are the cable, telephone, and internet lines supplying this subdivision. From the primary to the transformer steps down the voltage to 120 to 40 volts. Instead of doing an overhead service, we chose to do an underground service. The 240 120 volt service goes down this conduit, buried 36 inches underground to meet codes, and goes to the meter attached to the side of the house. At this meter, we have a main breaker that can stop the power before entering the breaker box. The meter then the power goes through the meter, then through a line that's in this conduit through the side of the house into the garage. This is the breaker box located in the exterior wall of the garage. I have removed the cover that covers up any exposed electrical components to reduce shock or arc flash hazards. Here, all the breakers are labeled accordingly, and at the top is our green final inspection for occupancy certification, allowing a tenant to live here. Inside the box is our orange rough-in inspection certification. This is done after rough-in is done and before any electrical inside the walls is covered up. This ensures that electrical is done properly before being allowed to cover up with drywall. In the breaker box comes in from the outside conduit are two main power wires from the transformer. This is our main service. We have a 200 amp service in this house, and at the top is our 200 amp main breaker, which when flipped off shuts off everything below. If needed to work on anything above this breaker, you must shut off the breakers shown to you below the meter on the outside of the house. At the top here is our green ground wire that goes back out of the house, where it will be attached to a ground rod, which is driven into the ground, grounding any electrical components out of this breaker box. On the sides, the silver bars are our ground and neutral bus bars, where we attach any ground and neutrals to complete the circuit, while also grounding them to the green wire. In the middle is our main power bar, each one of these tabs having 120 volts. When doing 240 breakers, they take up 2 slots because they attach to 2 120 volt bars, creating 240. Single 120 breakers just utilize 1 bar. The breakers in this breaker box are all arc fault ground fault breakers, which is required by Kentucky's electrical code. The arc fault ground fault breakers eliminate any potential fires from arc flashes from electrical components. They also reduce eliminate actually the need to have GFCI outlets inside the house because the ground fault is controlled inside the breakers. As you can see with the 110 or 120 breakers, there's 20 amp and 15 amps. 15 amps are used whenever there is a 14 gauge wire utilized in a circuit. Generally, houses are used 14 and 12 gauge wire for 120 volt purposes. As 14 is a smaller gauge wire, it can only hold the 15 amps of current to eliminate any potential issues with overpowering the small gauge wire. Also, when deciding whether to use a 20 or 15 amp breaker for a 120 volt circuit, you need to decide what the circuit is dedicated to. For example, code in Kentucky requires the refrigerator and the microwave, the disposal and the dishwasher all to be on separate breakers. Depending on the requirement for these units is what would decide how many amps each circuit needs to have.